Lesson 6.6, we're investigating sinusoidal functions. Now, we haven't really mentioned that to this point, the term sinusoidal. And basically, that term just refers to these smooth symmetrical curves like this, kind of like sine curves and cos curves. Anything that's nice, smooth, symmetrical waves are referred to as sinusoidal. So in the last lesson, 6.5, we looked at equations and then constructed our graphs. In this lesson, we're doing the exact opposite. We have our graphs, and from those, we're going to construct our equations. So to start off this note, I have two graphs here, and we're going to look at the amplitude, period, any phase shifts, and the equation for each graph. So looking at the first one, we want to determine the amplitude. So for part one, the amplitude, of course, the distance from the middle of our graph to the maximum or minimum point. So the amplitude would be 1. The period, we start here at the y-axis, hit the maximum point, come back down to the minimum. The period would be 180 degrees. Now, when we talk about horizontal translations or phase shifts, we want to start our graph at the y-axis. It's very important that we start at the y. So if I start here at the y-axis, my graph actually begins and starts right there. So because my graph is starting at the y-axis, there's no phase shift. The phase shift would occur if my graph didn't start here. Let's say my graph started at 90. If my graph started at 90, then I have a phase shift because the phase shift is just the distance away from the y-axis. So because I'm starting at the y-axis, there is no phase shift, so we can put NA for phase shift. There's no vertical translations either because the middle of my graph sits on the x-axis, right? Nothing's shifted up or shifted down. The middle of my graph sits on the x. There is no vertical translation either. Now, the important part is when we come to the equation. So I have the amplitude, which is 1. The period is 180. When you have the period, you still need to determine the k value, right? Because the k is what you put into the equation. So k is equal to 360 divided by the period. So in this case, 360 divided by 180 means that my k value is going to be 2. We talked about there being no phase shift, so we're not moving to the left or the right, and we're not moving up and down. Now, the next important thing is to determine whether it's a sine curve or a cos curve. Okay, so you start at the y-axis. Now, here at the y-axis, I'm at a minimum point. I'm at the bottom. Then I go up to a maximum and then back down to a minimum. So if I cover the rest of this up, this graph is a negative cos curve. Negative because it's been reflected. I'm starting at a maximum point of -1 rather than starting at +1 for a cos curve. Okay, so my equation could be y equals negative cos. My k value is 2. And then theta, because theta is what's representing my x. Or it could be negative cos 2x if we wanted. That's if I start here at the y-axis. Now, doing homework questions, if you look in the solutions or in the back of the textbook, they never state a negative cos as an equation. They always use a positive equation. So they don't look at reflections. So what they're doing is they're starting up here. They're starting their graph there at 90, at a maximum point, then back down, and then back up. So because they're starting here and not starting at the y-axis, the equation then becomes y equals cos, because my amplitude is still 1, 2 theta minus 90. So because I'm starting at 90 degrees rather than starting right at the y-axis, this graph as a parent function should be here, right? A parent function that starts right at the y-axis. And because it's not, I have this as a phase shift. because I'm starting here on my graph as opposed to starting at the y-axis. And that's where the phase shift comes in. It depends on where you start. So for example, what if I wanted to start my graph here? Start here, maximum point, minimum point, and then end up here. In this case, it now becomes a sine curve. So y equals sine 2 theta minus 45, because I'm starting at 45 degrees. So the truth is, it really doesn't matter what your equation is, because the equation depends on where you start on the graph. Now, most of the time you're going to start at the y-axis. But if you start somewhere else and you include a phase shift, then it really doesn't matter. So we could do a negative sign if we wanted to. I could start here and then go down to a minimum, up to a maximum, and then back and do a negative sine curve as well. Typically, I would just go with a negative cos because that's the easiest. But if you're looking in the textbook, they're going to stick with a positive cos. But if you did a negative cos on the assignment, then that would be completely fine. So if we look at the second graph, same thing. Now, when it comes to writing an equation, we want 4 things. We need P for the period, E for the equation of the axis, A for the amplitude, and then PS for phase shift. So peeps is what I usually keep referring to. So P is the period, so I'm starting at 0 to 120. I need to get the K value. So K is 360 divided by 120, which is 3. Equation of the axis, the middle of my graph, is at 0. The amplitude is still 1. And again, we'll say there's no phase shift because we're starting right here at the y-axis. So to come up with the equation, again, it could be y equals negative cos 3 theta, because that's the K value. Or if we want to use a positive cos, I would start here, minimum point, back to my maximum point. Y equals cos 3. Now, we're halfway between 0 and 120, so we're phase shifting over 60 degrees, so theta minus 60. Okay, and then of course you could do a sine curve as well if we want, where we're here. If this is 60, that would be 30. So we could do y equals sine 3 theta minus 30 degrees. Okay, all of those are correct as long as you include a proper phase shift. So for example 2, determine the equation of each function with the given properties. Now it doesn't say whether it's sine or cos. Sinusoidal does not mean it's sine. Sinusoidal just means it's these flowing waves. So the period is 360, which means that my K value is going to be 1. So my equation, we'll use sine for this one, is y equals amplitude, sine, K value is 1. I'm going 45 to the left, so theta plus 45. And then going down 2 units. For B, period is 720. So then K is going to be 360 divided by 720, which is 1/2. So y equals 2. I'll use cos for this one. K value is 1/2. Theta minus 60. And then plus 1, up 1. And that's how we come up with the equations. Remember, it's amplitude, K value, phase shift, equation of the axis. So 2 more examples where we have to come up with the equations. Example 3, a nail located on the circumference of a water wheel. So it's kind of like one of those paddle boats where you have a nail in the piece of wood on the water wheel. The height of the nail in terms of time, so the nail at the top of the water wheel and then goes of course to the bottom, back up to the top, back down to the bottom. We want the equation of the function. So again, we want peeps, period, equation of the axis, amplitude, phase shift. So if I start at the y-axis again, minimum point back to a maximum point, the period is 10. Now, even though the period is 10 in terms of seconds instead of degrees, it doesn't matter. To get the k value is still going to be 360 divided by the period. So even though we're talking about time here, not degrees, we still divide by 10. So my k value will be 36. Equation of the axis is the middle of my graph, which occurs at 1, right? Amplitude in that case, whoops. Equation of the axis 1, amplitude 2, and again, no phase shift because we're starting at the top of the graph on the y-axis. So that will be a positive cos curve because I'm starting at the maximum point. Max or min is cos. If my graph starts at the equation of the axis, that's how I know it's a sine curve. So because I'm starting at a maximum point, it's going to be cos. So they use h of t here for y, so I'll do the same. H of t equals amplitude. Now it's a cos curve. K value. No phase shift, so I can just use t here. Didn't really need brackets. And then my equation of the axis, which is plus 1. So 2 cos 36t plus 1 is my equation. Like I said, we don't really need brackets around this t, or even around the 36t, because there is no phase shift. But there's no harm if you put them in anyway. Example 4, a sinusoidal function has an amplitude of 2, period of 180, and a maximum at 0.3. I want the equation. So anytime it asks for the equation, we look for our 4 things. So the period is 180, it gives us that. So if the period is 180, we know what the k value then, 360 divided by 180, that k is going to be 2. We know the amplitude is 2, but it doesn't give me the equation of the axis or if there's a possible phase shift. So if we make a little sketch here of what this will look like, the function has a maximum at 0.3, so x value of 0, y value of 3. So let's say we're here. That's the maximum point. Then it kind of comes down and goes up, and so on. Now we have an amplitude of 2. Amplitude is the distance from the equation of the axis to your maximum point. So if that's my maximum, if I go down 2, it means that my equation of the axis, or the middle of my graph, occurs at 1. And if I go down another 2, they know that the minimum of my graph, the bottom, has to occur at -1. And because my first point here is a maximum, I know it's going to be a cos curve, and it's going to look something like this. So my equation of the axis is at 1, because I took the maximum point, subtract the amplitude to get the equation of the axis. And because I'm starting at the y-axis again, there's no phase shift. So if we're looking for the equation, y equals amplitude. Again, I'm starting at a maximum point, so it's a cos curve. K value is 2. And in this case, we can use theta. and equation of the axis is a +1. And that's how we get our equation. So 4 questions for you to look at for homework. And again, in these examples, we didn't look at any that were sine curves, because those are a little bit more rare, where you'd have a graph that starts at the equation on the axis. Mostly, for all these, you're starting at a maximum point for a positive cos, or you're starting at a minimum point for a negative cos. And if you remember the 4 things you need for PEEPs, you plug those into your equation, and that's it.